This lesson's on graphing functions. We learned in 9.1 that a function is simply a rule that has an input and an output. You put a number into the rule and another number comes out of the rule. That's a pretty simple one, but also helpful way to look at functions. You can describe functions also. You can see a picture of them if you put them on a graph. And the graphs, of course, involve ordered pairs. So another way that you can see how a function works is through ordered pairs. And it's pretty easy with an XY chart to do something like that. So if I make my XY chart, and I know a simple rule I'm going to use, and you'll probably figure it out really quickly. If I put in 0, 1 comes out. If I put in 1, 2 comes out. If I put in 2, 3 comes out. So the ordered pairs for this would be 0, 1. Remember that the first number tells you how far over you go, left or right. And the second number in ordered pairs, so it tells you how many units you go up or down. So to show 0, 1, I will go over 0 and up 1. And I need to make this a little bit larger, so bear with me a second. So I'll go over 0, up 1. It would put this point on. And then there are the points from my chart were over 1, up 2. And over 2, up 3. And you can kind of see how this is going, that it would go, if I connected these, it would look, and that I kind of got off track there, but it would be something that looks a bit like that. Let me bring everything back into the picture here. So this would be a graph of what it would look like. Notice that the graph actually crossed over both the y-axis here and the x-axis. I put enough of the graph in to see that. It crossed over the y-axis at 1, which would be noted that if I go over 0, I go up 1. So this is actually called the y-intercept. 0, 1 is the y-intercept. And where it crosses the x-axis would be at -1. So right here is the x-axis. And I hope you figure out what this rule was. It's actually, if I write it in sort of the standard form, which is to say what is the output number equal in terms of the input number, it would be x plus 1. So this is a way that I can describe the function by using an XY chart, or with ordered pairs. I can write the rest of them here. Also 1, 2, and 2, 3. So I describe it with ordered pairs by using this arrangement. I use an XY chart to show the function here. And this is another way to show the function. It simply writes out the rule. This way of writing is called slope-intercept form, and we'll learn more about that later on in the chapter. Let's take a look at another function. And I'm just going to tell you what this one is. It's y equals 4x minus 2. And I want to talk to you about, or show you a way that you can get the graph by just figuring out where it crosses the x-axis and where it crosses the y-axis. If I let x be 0, I'll go ahead and put my xy chart. Let x be 0. It's pretty easy to see that y would be -2, because this 4 times 0 would be 0, and then y would simply be equal to -2. So I know that I'm going to cross over, the y-intercept is going to be, it's often abbreviated this way, y-int is going to be -2. Now it gets a little more complicated to figure out what the x-intercept is, but to do that I have to let y equal 0, because I want to know what is x if y is 0. So I can say 0 equals 4x minus 2. And now I have a two-step equation to solve. I will add 2 to both sides to start with. So I get 2 equals 4x. Then how do I get x by itself? I have to undo multiplying by 4. And I end up with, I'm going to reduce 2 fourths. It's 2 divided by 4, which would be a half. So when y is 0, x is a half. And that, if I put these on the graph, then I can get a picture of what this line will look like. So 0, -2, and 1/2, 0 are my points. I'm going to go ahead and zoom in a little bit here. And I'm going to put on 0, -2, so I go over 0, down 2. I'm sorry. And it would be, let's put this in an outstanding color here. Let's try that green. Look nice, I think. So over 0, sorry, pink, that's fine. Over 0 down 2 is one, that's my y-intercept because it's on long, this is the y-axis. So it intersects or intercepts the y-axis at -2, and the x-axis was the intercept to the y. The x-intercept was 1/2, so roughly in this area. And then if I connect the two, I don't really need a straight edge to do a good job with this. It's kind of a rough drawing of what it might look like. That would, whoops. Give me an idea of what the x-intercept and what the y-intercept would be. And then the pink line kind of shows what the graph of y equals 4x minus 2 would look like. I could continue to do more of my chart here, which probably wouldn't be a bad idea. If x is 1, then I get 4 times 1 is 4 minus 2. Y would be 2. And go over 1, up 2, and it would be this point right in here. So it kind of, not bad. If x is, say, 5, that's going to put us off the chart maybe. That would be 18. And go over 5, and then up 18 would be way up in this area somewhere. But it kind of extends this line. So that's pretty much the info on how to graph a function. You can do an XY chart, and then always take at least 3 points, because 2 points will determine a line, and then the third point functions as a check for you. And did you notice, by the way, that both the graph we did here and in the first slide were straight lines? That's always going to happen. You'll get a straight line when y equals x to the first power plus or minus something, and you could have any coefficient for the x that you wanted to. So when your output number equals something that you do to the input number that doesn't involve powers, you get a straight line. If you got a little more complicated and said y equals something like 3x to the second power plus 2, then that's not going to be a linear function. It's not going to produce a straight line. It's going to go something more like way up like that direction. So in this chapter, we're working mainly with linear functions, certainly in this section today.